Okay, now let's differentiate it. What we have here is drift is equal to VR upon VM sec theta minus tan theta into d. So let's differentiate it. When we differentiate it, we'll get d VR upon VM. Differentiation of sec theta is sec theta tan theta. Differentiation of tan theta is minus sec squared theta into d. This should be equal to 0. Now this gives us, what does this gives us? This gives us VR upon VM sin theta upon cos theta is equal to 1 upon cos theta. Do we get this? This gives us, are you doing it along with me? You should be. If you are not, you're not going to learn anything. This gives us sin theta is equal to VR upon VM. So VR should be equal to VM times sin theta. Or sin theta should be equal to VR upon VM. This should be the condition for minimum drift. We have just differentiated the function and made it 0. The theta which will satisfy this, that the differentiation of that function would be 0, at that theta the function would be minimum or maximum. In this case it won't be maximum because drift maximum could be infinite. If you jump right in this direction, you will never reach to the opposite bank and the drift would be infinite. So definitely the maximum, this is not the condition for maximum drift because maximum drift would be infinite. This is the condition for minimum drift. So minimum drift would occur when sin theta is equal to VR upon VM, or theta is sin inverse VR upon VM. Okay? Okay. Then let's solve one problem based on what we have studied up till now. The velocity of the man with respect to river is, let's suppose, 5 km/h, and the width of the river is 1 km, and the velocity of the river is 3 km/h. Okay, now a man wishes to swim across the river directly opposite to the starting point. So this is the case in which the man wants to cover the minimum possible distance. It starts from A and wants to reach directly opposite to the starting point at B. So the question is, what must be the angle he should start swimming at? The angle at which he should start swimming, he should jump. You have to find that angle, and there's nothing you should remember from the previous theory except for the concept of vector addition. Now solve this. Take a paper and pen and solve this. Literally solve this as soon as you can. Okay, so if the man has to go just on the opposite side, this is the direction of the net velocity that the man should have. There's a velocity of river in this direction. So the velocity of the man should be something in this direction, like this. If we shift this vector here, we get this. So velocity of man with respect to river, velocity of river, and this is the velocity of man with respect to ground. So Vm vector plus Vr vector is giving you Vmg vector, velocity of man with respect to ground. That is the net velocity which the swimmer acquires. So this is again a right angle triangle, as you can see, and using Pythagoras theorem you can easily find out VAB. We know Vm is given, we know Vm, Vr we know, and you can find VAB. But they were asking you this angle, theta. So this angle theta can be found out very easily sine theta is equal to perpendicular, which is VR, upon hypotenuse, which is VM. VR is given as 3, VM is given as 5, sine theta is 3 by 5, then theta would be how much? Theta would be 37 degree. So the angle he should start off should be 37 degree with respect to the shortest path, or it should be 37 degree plus pi by 2 with respect to the flow of river. Flow of river is in this direction. With respect to flow of river, it would be this whole angle, right? So 90 degree would be added to it. So 127 degree with respect to the flow of river. Okay? Okay, then suppose in the second part of the question they are asking what should be the velocity of the man? What will be the net velocity of the swimmer, of the man, with respect to ground? They are asking VMG. Now using this Pythagoras, now you can very easily find out what is VMG. VMG will be equal to, tell me. Yes, 4. Yes, 4. Now suppose in the third part of the question they are asking what would be the time taken for the swimmer to go on the opposite side. Time taken for the swimmer to go on the opposite side. That time taken would be the width. Width is given as 1 kilometer upon the velocity along VAB, which has come out as 4 kilometer per hour. Now it covers 4 kilometer per hour. So it would take 1 by 4 hour to cover 1 kilometer. So the time taken would be 15 minutes. 1 by 4 of an hour. Fine. Okay. This was simple, easy.